You said 1 to the power of 9.
Where?
Number 3.
Well, it's 1.4 to the power of 9.
Yeah. I did 4. I did 1.5 to the power of 9.
Okay. All right. So Ash said she would like to see 4. Now, a few people asked about 4 yesterday during class. I went over it a little bit with a couple of people. So we'll go over everything right now. But actually, I don't want to do the question. First, I want to prove that you actually know how to do this question. Not just you, everybody. If I gave you this, x squared over x times x to the 5th, what would you do to simplify the denominator now? Right. It would be x squared over x to the 6th, right? And then what would you do?
Divide.
No, you don't divide. It is division, but that's not what we do. What do we do?
Minus.
Subtract, so that would be x to the negative 4, yes?
Yeah.
And since that's x to the negative 4, that's really x over 1, right? So really, that's really x to the... Yeah, loving it. That's what that really is. And then the negative 4 would go to everything, x to the negative 4 over 1 to the negative 4. Negative's not allowed, so it would come up to the top. Negative's not allowed, so it would go down to the bottom. And that would be the answer, right? Everybody can follow that, yeah? Okay. How is what you just did here, which you all said you could follow, any different from this? These are all the same base, yes? Right? So it's just like having an x. So we'll start with where we can simplify. I can't do anything to the top because there's only one thing there. But on the bottom, what would you do with 1/3 and 5/3? It'll be 6 over 3. Right? Okay. So now I have to do I have the same base? So I subtract the exponents, yes? So it is 2/3 minus 6/3. What is that? Negative 4/3. Right? So now I have my base to a negative exponent. That's not allowed. So it's 1 over 7 to the 4/3. And that's done. That's the exponent version. Right? That's the right answer. But based on your very last lesson, you could go one step further. And when you have a fraction in the exponent, the denominator becomes the index, the base becomes the radicand, and the whole thing becomes the power. This is also right. Okay? This one is called exponential form. And this one is called radical form. They're the exact same thing. So that what I would do to prove if you want that 5 total understanding, I would say, I wouldn't just say simplify. I would say simplify this to exponential form. Or simplify this to radical form. Right? If I just said simplify, both of them would get you the full marks available to you. Yeah? Questions? Everybody good? Sweet. There's 5 and 6. Does anybody need to talk about either of them? Going once. Twice. Somebody say they need to talk about it because I'm trying to find something in my backpack. Okay. No, still? Fine. $109. There's the first two. Anybody need to ask about either of them? Sweet. There's 9 and 10. Same thing. The exponent form or radical form, they're both exact the same thing. I don't care what you have. Everybody still okay there? Yes. 12. Oh, well, we didn't even get down there yet. But is everybody okay to 10? And I assume everybody then is okay with 11? Yeah? All right, let's talk about 12, why it's 2 to the 48. I'm going to slide that over there. And we're going to discuss why this is the case. Where should you simplify first in this mess? Do you think? What tells us the rules of how we do math? Bedmass, excellent. So where should we start? Brackets. So I got to start with brackets that have math operations inside them, right? So these brackets right here have a math operation inside them, correct? So now that I know I've got to work in there first, I have to decide where in there I'm going to work. What's the next? What's the E stand for? Exponent. So I better deal with this, yes? Everyone agree? Now, so since I'm dealing with just this right here, what does that mean? What does that little 4? Don't tell me what to do with it. Tell me what it means. What does that little 4 do to the base? Corey?
That little 4 means everything inside the bracket is to the power of 4.
Right. So that would be negative x to the third, right? How many times? 4 times. Agreed? Everyone agree? Okay. Now, what then do I do with all these exponents when I'm multiplying? What do I do? Hold up, not yet. What do? I add them. So this would be negative x, that's the whole base, right? To the 12. Agreed? So that is what this whole bit right here becomes. Everybody cool with that? Now, if you take a negative base to an even exponent, isn't that the same as a positive base to that same exponent? It is, right? So this is really x to the 12th, yeah? What else is inside these brackets? That x to the 4th, right? So I also have an x to the 4th here, multiplying with that x to the 12. What's that? Not yet. What's that? That's x to the 16th, yes? And then that whole 16th is cubed. So over the bracket, what do? Multiply, so that's x to the 48th, yes? Now, what is x? Negative 2. So this is negative 2, that's the whole base to the 48th, right? Which is exactly the same as 2 to the 48th. Both of those would be acceptable. Does everybody understand? Where most kids screw this question up is they're unsure about that negative base bothers you, right? But what you got to remember, and the reason that negative thing works is what I'm about to show you now. What would that be? Negative, negative, negative. That would be a negative, wouldn't it? Negative times a negative is positive, times another negative is negative, right? What would that one be? Negative. What would that one be? Negative. What would that one be? Negative, right? Negative times a negative is what? Positive. Positive times a negative is what? Negative. Negative times a negative is what? Back to positive. Does everybody understand? It's not anything you don't know. It's just weird to think about it, right? Because a negative base is allowed, but you got to remember that negative 2 squared is the exact same thing as positive 2 squared. They're both 4, right? But negative 2 squared is not the same as positive 2 squared. And it's not the same as negative 2 squared. Did you hear the pause in my voice? This is negative 2 squared. This is negative 2 squared. In this one, the negative comes along for the ride. In this one, it just hangs out front and minds its own business. Everybody cool? So that's why that one's tricky. And I put it there on purpose just to see what would happen. Now, of course, you could also have just put the numbers in right away, right? And that would have worked too. Then, when you put the numbers in right away, if you do it that way, which, by the way, I do not recommend, always simplify first. But if you put the numbers in first, that's negative 2 to the 4th times negative 2. Because x was negative 2, and there's a negative out in front. So negative 2 would make that positive 2 anyway. Everybody understand? Okay. Turn the page over. This is the best answer. But a lot of you guys and ladies have trouble with algebra. So I'm just going to take a moment and go through it again. That's the formula for volume of a sphere from Unit 1, right? Okay. That's the volume, right? So all I got to do is get R by itself. So how do I get rid of the 3? Times by 3 times by 3, which is 1,275, yeah? Equals 4 pi R cubed, right? How do I get rid of the 4? Divide by 4. Divide by 4. Now, if I'm going step by step, I should divide that by 4 right now, yeah? But if I know what I'm doing, I can also look over here and say I also need to divide by pi, don't I? So if I divide by pi there, I'm going to divide by pi there. Now, here is where you all will make your mistake. You don't actually know how your calculator works, even though you insist on using your calculator for absolutely everything. If you punch this into your calculator, 1,275 divided by 4 times pi, your calculator is going to give you the wrong answer. Because your calculator does BEDMAS. It's going to divide by 4, and then it's going to multiply that answer by pi. And that's wrong. Because we don't want to divide by 4 and then multiply by pi, do we? What are we trying to divide by here? 4 pi. So I got to remember brackets. If I remember the brackets, it gives me the right answer. And it gives me R cubed to be 101.46 or some crap like that. And then how do you get rid of a cube? You cube root. Now, a lot of you can't do that in your calculator. And if you did do that in your calculator, you'd get something like 4.67, which is fine. But remember, as we go further in math, we want our answers to be exact, not an estimated decimal. So what we want from you in the future, when you get to this point right here, R cubed equals 1275 over 4 pi, from now on, this is your answer. You know you got to cube root that, so all you do is you write cube root of that, and you leave that as your answer. Does everybody understand? Now, for my purposes in my class in grade 10, I'm perfectly happy to accept that. Because if you get to 4.67, you understand the algebra. Everybody cool? All right. Same thing down here, except we're doing the volume of a cone. So the volume of a cone, that's a highlighter, you idiot. The volume of a cone is pi r squared h over 3, right? Except there's something special about r and h here. What is it? They're the same. So if h and r are the same, isn't the volume of this cone pi r squared r again? over 3. And then what do I do with r squared and r? What do I do with the exponents? Add them up. So it's pi r cubed over 3. And what does that equal? It equals 18. How do I get rid of the 3? Times both sides. Pi r cubed equals 54. How do I get rid of the pi? Divide by pi, divide by pi. R cubed equals 54 divided by pi. Now, what would we do to do the answer perfectly the way we want to see it for the rest of your math life? Just cube root that and you're done. Okay? If you're going to do it with a calculator, it's going to be 54 divided by 3, which is around 18. And then the cube root of 18 is somewhere around 2.5 would be your answer. Great. Both of them are acceptable. This one is better. Okay? Everybody good? All right. Now, it's 1:30, which means I'm leaving you with 50 minutes. Oh, wait. Now I'm the liar. Did anybody do any of the extra practice that I had offered for you on page 111 or 112? And if you did, would you like to discuss any of it? Nope. Okay. No, it's coming from the speaker because I just touched this and I touched my computer. So now I'm making a circuit. Just like if I brought it over. Huh? No, because 2 reasons. 1, there is all kinds of proof that the kind of music you people will want to listen to while you're working actually is detrimental to your brain. It actually makes work harder for you to do, which is why I do not understand. Yes, country. No. Smooth jazz has no place anywhere in the world. But the actual best type of music to listen to is instrumental music in 4/4 time. Because if it's not in 4/4 time, if it's faster than 4/4 time, you make errors of omission, which means you leave stuff out. When you make it slower than 4/4 time, you make errors of commission, which means you put extra stuff in. And when there's words, you don't have full access to your prefrontal cortex because even though you're not thinking about it, your brain is listening to the words to the song. So if you really want to do well at anything, you would listen to instrumental music in 4/4 time.
Isn't it called common time?
Huh?
Isn't it called common time?
I don't know. I'm not a musician.
We're in band kids. We know what we're talking
Yes. All I know is 4/4 time is 4 beats per bar. That's all I know. Huh? You want me to throw on some 4/4 time music? Great, sure, I'll do that. Now, but listen up, please. Where the heck is it? On page, I believe, if I'm not mistaken, page 114 begins the review. That is for marks. Don't look. Answers. Danger, Will Robinson, danger. There. Whew. Page 114, exponent and radicals review. This is what your test on Tuesday will be on. Till 117, yeah. All right. Now, there's a couple of printing errors in here. Let's find them. I know there is. Actually, there doesn't appear to be. Son of a motherless goat. No, there's none.
Son of the motherless goat.
No printing errors. I fixed this one already. All right. I'm giving you the rest of the period to work on this. If you get it done, terrific. If everybody gets it done with some time left before the end of class, then we'll do some marking. All right? If not, we're marking it first thing Monday morning, starting our new unit Monday morning, and you will be testing on this stuff on
What's the next unit?
Tuesday. Next unit is polynomials, brother. What? Oh, Monday morning, we're marking this. Tuesday afternoon, we're writing the test on. What? You're not going to be here, no? Oh.
The really hard exponent.
That's not for you guys. No. That is this. Simplify some of those bad boys.
Actually, I'm coming out on the from the middle. So it's like
What?
we get back about 1:50.
Oh, right. Because you guys aren't here till the afternoon Monday. That's what Ash was doing. Yeah. Okay. Yeah, we'll mark it on Monday. And we'll wait till everybody's back.
When I come and then we mark it and then I get it back to like 30 something.
What do you all back?
No, if I
But Ayla, we're gonna mark it on Monday when you guys are back from your field trip. We'll wait till you're back.
Oh, okay.
Okay? Then you'll have it to study from Monday night for your test Tuesday.
Listen to Beethoven.
Beef oven?
No, Beethoven.
Beef oven?
Yeah, just say yes. Just say yes.
Yes.
Oh, do you
Cut time would be
use
4-2 because half of it's a D and